Hi, so this is our final project for data structures and algorithms. This is a UF scheduler that we made here. The group members consist of me, Surya, Karthikeyan, Lakshmi, Andy, Chen, and Weedguet, Mildort. Uh, the issue and problem that we were trying to solve was just to create a more cohesive way to see all the classes for a major. We also went one step ahead, and we can let the students or the user choose the classes that they've already taken, and so it really creates a bigger picture of what more classes they need to take, its prerequisites, as well as the details of each class. We accomplish this using the adjacency list, which I will go over later after Andy provides a demonstration of the code or of the website.
Hey, so my name is Andy Chen. I'm the front end and back end engineer, and I also provided or scraped the data for this project. So you see on this website, we have a little help button, provides a little description of what our website does. Basically, you enter your selected major and completed classes to generate a graph of prerequisite classes, so you can figure out what classes you take in order. So, for example, we'll put computer science into this field and we'll put our complete classes. I'll just put a few example classes such as Calculus 1 and Calc 2, and I'll just throw in some computer science classes, 3501, 3502, and all we got to do is just press generate adjacency list. And right now it's sending a post request to a backend server running on a separate website. And it sent back a base64 encoded PNG, which we decoded here. And we could see a directed graph of all our prerequisites. So here we could see, for example, Calc 1 is a prerequisite for programming 2, programming 1. Programming 1 is a prerequisite for programming 2, and programming 2 is a prerequisite for discrete structures. Here we have the credits for each class displayed here, and as well as the total credits, which compiles all these together. We also have random colors generated for each course by hashing the course code and course name to get a set pseudo-random color for each course to add some just visual appeal. Furthermore, if you look at these classes here, we can expand these, get a description, as well as the meeting times for each section and the teacher, for just for information. You can also double click on each badge to add it, along with the plus and minus button, and as well click from here to deselect it. Furthermore, all these fields are saved into the local storage of the browser. So, for example, if we close this tab and reopen it, everything persists. All right, I'll hand it over to Surya to describe his data structure.
Yeah, so I went ahead and implemented an adjacency list to store this data. I chose to do this because I knew that it would be more of a sparse graph than a dense graph because while classes have prerequisites, that doesn't necessarily mean that they connect to the other nodes, which is why we result in a fairly fast load time over here. And a little note about the load time is that the on the top right, the time you see there is what it took for the code to create the adjacency list, to initialize the adjacency list based on the major. However, you can see that the display is kind of delayed, and that's because we use a different library to actually display it. The library that we use is NetworkX and matpointlib, which is just a helper function for NetworkX, and we just display it using that library.
Yeah, so the main delay you see is because of the just basically the server connection and the network X displaying, but this measures the time of our actual data structure.
Thank you.